In this lecture, we will discuss operating on data in Pandas, saving the file by the new name. One of the essential pieces of NumPy is the ability to perform quick element-wise operations, both with basic arithmetic like addition, subtraction, multiplication, etc., and with more sophisticated operations like trigonometric functions, exponential, and logarithmic functions. Pandas inherits much of this functionality with NumPy, and the ufuncs that we introduced in the last section, computational NumPy arrays, universal functions, are key to this. Pandas include a couple useful twists. However, for unary operations like negation and trigonometric functions, these ufuncs will preserve index and column labels in the output. And for binary operations such as addition and multiplication, Pandas will automatically align indices with when passing the objects to the ufunc. So this means that keeping the context of data and combining data from different sources, both potentially error-prone tasks with raw NumPy arrays become essentially foolproof ones with Pandas. So we will additionally see that there are well-defined operations between one-dimensional series structures and two-dimensional data frame. So now let's discuss ufuncs, index preservation. So because Pandas is designed to work with NumPy, any NumPy ufunc will work on Pandas series and data frame objects. So let's start by defining a simple series and data frame on which to demonstrate this. Starting off with import Pandas as pd, import NumPy as np. Now rng equals to np dot random state 42 scr pd dot series rng dot branded in the bracket 0104 scr. Run attribute error scr is equals to pd dot series rng dot randit rand int. Okay, so we got the output. So df now df is equals to pd dot data frame rng dot rand int 010. Now open the bracket again. For columns is equal to square bracket a b c d. A b c d, square bracket close. df. Now we got the result. If we apply a NumPy ufunc on either of these objects, the number will be result. The result will be another Pandas object with the indices preserved. np dot expcr. We got the result. So, or for a slightly more complex calculations, np dot sin df np dot pi divided by 4. We got the result. So any of the ufunc discussed in the last section of NumPy can be used in a similar manner.